Hi, my name is Sam, and I'm going to be talking about the seven bridges of Konigsberg. Alright, so basically there were these seven bridges in the city of Konigsberg, and then and the green is the land and the blue is the water, and people basically wanted to see if they could cross each bridge once without retracing their steps. So the guy who tried to find a solution to this was Leonhard Euler, but he ended up discovering that it wasn't possible. So, like I tried to show here, he converted this graphical image into, like nodes and vertices. So he put vertice right there for each land and then connected them through the bridges. As you can see, they're connected here, connected here, connected here, here, and so forth. But this might be a complicated photo, so an easier photo to visually see it better can be represented by this. And so he put a dot for the areas of the cities and lines for the bridges. So with this, he noticed that the nodes could be even or odd. He basically noticed that they were odd, but they could have been even or odd. So you can see this has 3, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3. So with this, since they were all odd, like it was basically impossible to do. So in an odd node has an odd number of vertices, and an even node there's an even number of vertices. And if the node is in the middle of a journey, then you have to have a bridge to enter and a bridge to leave each time. So enter, exit, and then with the third one, it kind of makes it odd because then you get trapped. So the number of bridges will always be a multiple of 2 in order for there to be a solution. So if the node is odd, you have to either start or finish at that node, otherwise you'll get trapped. So basically, going off this rule. The problem with the bridges of Konigsberg was that all the nodes were odd. As you can tell over here, they're all odd, so that obviously contradicts the statement. So this meant that wherever you started or finished, you'd end up getting stuck. And the easiest way to solve the problem would be to have taken this line out, because then you would have 2 odd and 2 even, which kind of goes with this statement mentioned above. So there would be 2 odd nodes and 2 even nodes, and as long as you start at an odd node and end with an odd node, the route is easy. So to like visually demonstrate that, I could start right here at the odd node, go here, 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 there, there, and there. So I'd be touching each line only once, which would be part of the rules. So yeah, this is the 7 bridges of Konigsberg and the solutions. Even though there is no solution, but there's a possible way to get it. There you go.